acids, bases, and salts. In this lesson, we are going to learn about acids, bases, and salts. In our daily life, we use a large number of substances such as lemon, tamarind, common salt, orange juice, curd, amla, grapes, unripe mango, sugar, and vinegar. They all have different taste. Some of these substances taste sour, some taste bitter, some taste sweet, and some taste salty. Acids and bases. Curd, lemon juice, orange juice, and vinegar taste sour. These substances taste sour because they contain acids. The chemical nature of such substances is acidic. The word acid comes from the Latin word acere, which means sour. Baking soda is bitter in taste. It has no acids in it. If you rub its solution between the fingers, it feels soapy. Substances like these, which are bitter in taste and feel soapy on touching, are known as bases. The nature of such substances is said to be basic. A turmeric stain on white shirt is turned to red when it is washed with soap. It is because the soap solution is basic. Indicators. We cannot taste every substance. So to find its nature, special type of substances known as indicators is used to test whether a substance is acidic or basic. The indicators change their color when added to a solution containing an acidic or a basic substance. Turmeric, litmus, China rose petals, gudhal, etc. are some of the naturally occurring indicators. Acetic acid found in vinegar. Folic acid found in ant's sting. Citric acid found in citrus fruits such as oranges, lemons, etc. Lactic acid, acid found in curd. Oxalic acid found in spinach. Ascorbic acid, vitamin C, found in amla, citrus fruits. Natural indicators around us. Litmus, a natural dye. The most commonly used natural indicator is litmus. It is extracted from lichens. It has a mauve, purple color in distilled water. When added to an acidic solution, it turns red, and when added to a basic solution, it turns blue. It is available in the form of a solution or in the form of strips of paper known as litmus papers. Generally, it is available as red and blue litmus paper. Activity. Take 2 beakers. In one beaker, take a solution of lemon juice and in the other, a solution of quicklime. Dip 1 red litmus paper and 1 blue litmus paper in each. In the lemon juice solution, the red litmus paper remains red and blue litmus paper turns red too. On the other hand, in the quicklime solution, blue litmus paper remains blue and the red litmus paper also becomes blue. The solutions which do not change the color of either red or blue litmuses are known as neutral solutions. These substances are neither acidic nor basic. China rose indicator turns acidic solution to dark pink, magenta, and basic solutions to green. Activity. Take dilute solutions of hydrochloric acid, sulphuric acid, acetic acid, sodium hydroxide, and calcium hydroxide, slaked lime in separate beakers. Add litmus paper and phenolphthalein to each of these solutions and observe their reactions. In hydrochloric acid, the blue litmus paper turns red, but the red litmus paper remains unchanged. In phenolphthalein, when the solution is acidic, there is no change. In sulphuric acid, the blue litmus paper turns red, but the red litmus paper remains unchanged. In phenolphthalein, when the solution is acidic, there is no change. In acetic acid, the blue litmus paper turns red, but the red litmus paper remains unchanged. In phenolphthalein, when the solution is acidic, there is no change. In calcium hydroxide, the blue litmus paper remains unchanged, while the red one turns to blue. It is evident that when the solution is basic, phenolphthalein gives a pink color. In sodium hydroxide, the blue litmus paper remains unchanged, while the red one turns to blue. It is evident that when the solution is basic, phenolphthalein gives a pink color. The above experiment shows that litmus gets on retaining a red color in an acidic substance, while it gets on retaining a blue color in a basic substance. The acidic or basic property of a substance can be identified by the color of the litmus on coming in contact with it. That is why litmus is known as an indicator. Substances which do not cause litmus to change its color are known as neutral substances. Elements fall into two groups, metals and non-metals. The examples of metals are iron, copper, aluminium, calcium,
magnesium,
etc. The examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc.
When magnesium ribbon is burnt in air,
it combines with oxygen in the air and forms
magnesium
oxide. When metals are heated, oxides are formed. Twice Mg plus O2 gives twice MgO.
Magnesium,
Oxygen.
magnesium oxide.
Activity. Take some powdered sulfur in a deflagrating spoon. Heat it over a burner or a spirit lamp. Soon, the sulfur begins to burn. Now, quickly put the spoon in a jar and close the lid of the jar. The yellowish sulfur dioxide gets collected in the jar. Move the lid aside a little and remove the spoon. Add 20 to 25 ml of water to the jar. The gas in the jar dissolves in water and we get a solution. SO2 plus H2O gives H2SO3. Put red and blue litmus papers in a solution. The sulfurous acid, the blue litmus paper turns red, but the red litmus paper remains unchanged. That was all about this chapter, students. Happy learning!